What is up? Hanging out in the Frankenstein laboratory. Been kind of avoiding the space for a little bit because it's kind of warm. And speaking of that, I got the air kicked on. It's down to a whole 79 degrees. About 60 degrees blowing right on me though. So it feels pretty okay. And outside I added some mister nozzles onto my little outdoor coil to kind of allow it to run a little longer. When the storage tank and the water heater is already over 130, it's not able to reject enough heat to keep the pressures happy. They start getting a little high. Not as high as I thought they would be, but up there. And then the performance goes to shite, especially since it's a capillary tube system, so you start getting a little bit of hot gas in there. It really starts underfeeding the indoor coil. So I have some misters outside. Might show some on the screen here in the edit. Just spraying on the coil, doing a little bit of work. I just have those kicking on through a solenoid valve when the compressor out there kicks on. Real simple. But up here, you kind of see I have like my controller, which is a couple different pieces all added together, relays, everything. It's a little bit of a mess, although it just works and works and works. Doesn't ever screw up. Kind of stages my pump onto two different speeds to keep a minimum heat rise when the water is cold. When cold water from the dip tube comes down and goes out to the heat exchanger, if it comes back too cold, I don't want it to, put cold water back in the top. So the simple way for me to fix that was I just monitor the liquid line temperature, which corresponds with the temperature of the water going through the heat exchanger. So I just make sure that temperature gets kind of warm on the liquid line to over 100 degrees before it kicks the pump on low. And then when it gets up to like over 110, it kicks it to high. Same thing as putting like a little thermostat on the water, to maintain a minimum heat rise. It's been working good. But now it's summertime, I added a mister. So since I've made these control boards here, there's two more of them over here. These ones I've already kind of finished putting my components on it. Had to add a couple things. I forgot to put the capacitors on my circuit here. This is like 24 volts AC, goes through the resistor, diode, and to the optical isolators, right? And to the processor to switch to 5 volt logic. Well, I forgot to put the capacitors on there, so it just puts a 24 volt rectified ripple into the optical isolator, which will make on off, 60 times a second to the input. That's not what you want. So easy fix. I just solder on some capacitors, put another filter one here I found that kind of likes to kind of combine the common of this circuit and this circuit together just for noise, and I got it working pretty good. And kind of done the same thing here, except for put the capacitors on the bottom there. Also added a couple more components over here because I did leave spares connections in case I want to modify this for something else. So I did not make this board for this hybrid water heater, heat pump / AC unit in here. I made these boards for my little slim unit on the garage. It's still just been sitting there because it's hot already for the summer, but I have a couple different control boards in there, and these are going to replace most of those control boards. And rather than just milling these boards myself, I designed it like that, and then I just had these made. So most of these parts came on here, and some of the parts they didn't have, and I didn't want to go back and change my thing to find parts they could source there locally, so I just didn't put the buttons or the optical isolators, and most of everything else they came like this, and then I put in the last couple components like that. Pretty not too expensive. I think I spent like $80 for 5 of these boards. It's either 5 or 6 boards you get. So these are actually programmed and seem to be kind of working for what I want out there. It's got a couple temperature sensors for defrost, outside air, coil temp, a couple different things. It's mainly just going to be switching the VFD drive here and the reversing valve. Also has high voltage coming through this isolated section up here that runs that inverter fan out there. It's going to connect to that inverter board out there. So on this one here, I've just modified it by adding some other stuff and just kind of reprogramming it. So this is going to be a little different in here. So we got the compressor, pump low, pump high, and I'm probably going to have to add a couple other outputs. I got output. I'll probably hijack my pulse width modulated output just to turn on the fan out there. But I also need to. I thought maybe I should also control that mister also. So I might have to connect some extra spares to that. That's pretty easy. I got plenty of here, which I can just plug in, or some I could solder on. But let's just turn it on. I'm just meaning to make a short video, and I'm going to go too long. But program just a little different than the other one. I just have my basic stuff. The ones that say 250 is just because there's nothing plugged in, and that's kind of what the voltage divider does. When it's not there, it's almost a max value. So I got liquid temp, suction temp, water heater temp for the water heater, outside air temp, defrost. So I have a couple of those just kind of right here. The two that are important, like I said, is the liquid line temp and the water heater temp is going to be important too. And I'll show you why. So and I have all the inputs and logic working great. So right now it's just in standby mode. So yellow is going to be my Ecobee, which kicked it on to cool. So kicked the compressor on. Right now the two pump relays are off because the liquid line temperature is below 100. So I think this one hooked up to my liquid line temperature. So I start warming that up just a little bit, get over 100. It's going to click on the pump into low. And then if I go over 110, it's going to, I jumped it a little bit, but went to high. So it's a little touchy on the pot because I'm just at the very last little bit of range right there, the way this is kind of set up. And then the other thing I do is, say I'm in hybrid mode, and say, not hybrid, but cool only mode, which is what I'm right now, right? So, which is what this is doing. Like my water heater thermostat right there is not on because it's set for 126 and it's 134. I'm overheating the tank. Something I don't mind to do, and I've had it up to 145 the other day. The wife come and complained, saying there was no cold water because mixing the 90-degree summer cold water with that made it hard to kind of cool it off. But say I'm going to set a high limit for 150, right? Because whenever this thing's running a cooling, that pump is running on high speed, so I'm still heating the water, even though I'm trying to cool the room right now with the thermostat. And I have that little bit of water misting on the coil out there, just because there's a little tiny condenser coil put out there, because I need to keep the volume small for it to be efficient to reject heat. It just seems to work that way with that little compressor. So I'm cooling secondary heat when it's 110 out with a couple misters spraying on it. I want to control that there, but all I have to say, I'm able to use it for cooling right now primarily. But if it gets my water tank too hot, say I run this for hours and the water heater just keeps going up and it's going to hit 150, well, basically I'm going to monitor the water heater temp, and if water WHT is the middle one there, I just turned the knob, it clicked off the pump. So the compressor will be running, the outdoor fan will be running. See, fan high speed, now it says high temp because the water heater is over my high temp set point. And so if you don't circulate water from the heat exchanger, it's not going to keep putting heat into the water heater. Now at this point, it'll have to keep rejecting heat only by the secondary small condenser coil out there with the water spraying on it. But perhaps with enough water to spray on it, it'll be okay. It's also probably hardly ever going to hit that scenario, but I just figured I'd put that ability in there. And then, of course, as soon as the water heater cools off, it'll allow the pump to run again based on liquid line temp. And a lot of these settings I could always go in at any time, like I always do with my menu. Oh, what I do, I push something. It's been working so good too. So, without this grounded good, or I'll be touching something, sometimes I'll wax it. But adjustments, there's your defrost interval, 90 minutes is pretty common. I can adjust that up and down. Defrost set point of when it time and temperature, right? So 90 minutes, and if the defrost sensor goes below 28, when that 90 minutes rolls over, that's when it's going to initiate a defrost. Then you got your defrost termination point. All these are I can adjust up and down. My fan minimum and fan max for my pulse width modulation, so I can crank that up if I want. That's almost 50% duty cycle there. And then of course I can just keep editing exit or save. So it saves, it's going to go to the EEPROM. So of course See how the fan speed's 125. So now, next time I turn this power off and back on, the little EEPROM memory that's built into that will load that setting for max. And then the way I have this also is, say I was just cooling with the water heater, needed heat because somebody's using it. You could turn that on. It's not going to actually change anything because it's already going to be heating, but in that case it's going to say hybrid because I have a demand from the water heater and still a demand for cool in this room, so I just call that hybrid. And then if my room satisfies why the water heater's still heating, I just have to turn off that thermostat. It just goes to the water heater. Probably should focus on this. I'm just turning on and off my inputs over here with my little jumpers for now. But think of these are 24 volt inputs, so that's water heater, and the yellow is my thermostat in here. So right now it's just water heater. And say it warms up again in here, which it will, this mechanical room does. Then you can turn on thermostat in here, it just goes to hybrid again. And if the water heater satisfies, it'll unplug, it'll just go to cooling. You can switch anywhere between those two while it's running, no problem, because it just keeps the compressor running. But if both of them turn off, then it's going to go to off mode. And then I got my delay on break, of course. So say I need to cool the room again before that. Probably be 5 minutes when I'm done. Right now I just have it like 55 seconds or something. But I could always push I always put bypasses in there, counting down the last couple seconds, and I'll go back on again. So it's 2 relays you heard click real quick there. The compressor, and then looks like a low speed pump because of the liquid line temp. Again, if I go up, then a high speed relay goes on. And then all the way off if I turn the liquid line down. So back up. So pretty cool. The logic's all working fine for that. So this is almost done. I can when I get a chance, I can replace all that. I almost want to get another project box and leave that one there. Just to start hooking this up. Maybe just use some spare thermistors and everything. And like I said, I had to add some more thermistors. So at this point, I had to add a couple capacitors down there, but that's all it took, and adding in the programming for those 2 other thermistors, water heater. When there's analog 0, which is hexadecimal 81, analog 1, which is 85. And then other than that, you just got the same program. And then you're just reading an analog register and then copying it when it's done with the read into your variable with water heater temp, suction temp, defrost temp, liquid temperature, outside air temperature, stuff like that. And then I just have it displaying it on the screen. And yep. Trying to remember why I'm doing temp calculation before this. Whatever, but it's working. My temp calculation is my little voodoo. This stupid equation. It used to be, it's still up there, thermistor. It's within a degree or so without using all these different ideas you can use to read that slope of a 10K NTC type thermistor. They're actually not a linear slope. So I kind of have it just making this correction as it deviates, and that keeps it within a degree or so from the one end of the slope to the other. It's close enough for what I do, and I just use that same calculation on all my projects now. It's probably, when this breaks down to assembly, it's probably a whole slew of code, but it's still nothing like having a whole big lookup table or something to have to write in there. So it works. And you can condense down all these advanced my menus to go through and make my adjustments. My off subroutine, pump control, cool, hybrid, and water heater, which is basically the same as this except for the display just changes. My main would initialize the processor and all the registers, the bit registers, and everything for all the timers, selecting analog bits, all that kind of stuff. And my main loop, it just goes through here, and whatever the mode is where it's going to break off to those subroutines above. And it always has a high pressure safety in that loop. So if I unhook that, it goes to shuts down the compressor, keeps the fan and pump running, and it's going to go, into there until that closes, and then have a delay on break. So it always goes through the subroutine and deviates to whichever one of these it breaks off to, and then goes through the reading thermistors. And this is my one interrupt subroutine right here, which just looks for a change on port B, which could be the buttons here or these logic level switching from the output of the optical isolators, which is generated from the 24 volt switching inputs thermostats. Yeah. And pretty basic. And just to select modes is just, I have it check inputs every time after it comes out of the subroutine. It goes here and just looks to see the state of these. It works pretty good, and that's how it's detecting. Like if I change one of these inputs and I add one, well, one of those port B, one of the inputs on port B changes. It's going to go to the subroutine. I should change the hybrid. It's going to go to the subroutine and then go here, and now whatever the combination of those inputs are determines a mode. Mode 0 is neither on, so it's off. By the way, 0 is off and 1's on because I ground the inputs. Using the weak pull-ups inside the chip, I don't have to use pull-up resistors or pull-down resistors. It's just each one of these inputs just goes to the optical isolator. There's a transistor, basically optical transistor output, and then all these are grounded, right? This is one big ground. So they're all just ground. It just pulls it to ground. So when you don't pull it to ground, the weak pull-up, it's like internal resistors pulling that logic level up to 5 volts. So that's why my logical on I'm looking for is pulling it to a 0. So anytime you see 0, that's when my input's on. You have to remember that when you're writing the code. So both being a logical 5 is mean none are on, and it's mode 0. And then just cooling demand is mode 1. Both is mode 2. Just the water heater is mode 3. And then if I push this button when it's not in the menu already, that just changes to mode 6. Mode 6 goes over and copies my past mode. This is the kind of shit you just come up with and it just fucking works. But it seems stupid, but it's like, I don't know if the pros do anything like this or if my mind's just different, but I'm sure it ain't anything unique. But mode 6 goes over here, and I always have it. I throw in this kind of stuff sometimes in case like I unplugged and plugged in this like LCD or something, right? I plug it back in, it's no longer initialized, right? So when I hit that button and it comes out of the subroutine, it goes, okay, you're in mode 6 now. Restores the interrupts, goes out, boom, comes down to here, you're mode 6. What's mode 6 going to do? It's going to go run these two subroutines, initializing my LCD, and then it's going to copy my mode into last mode, and then it says mode now 5. So as it loops the next time after doing all those things, it's going to go to my menu. So every time it's looping through, it's going to my menu, and that's where all that menu stuff is to adjust things. So when I push menu now, can you see it with the player? It's a menu button right there. Menu, plus minus, I kind of had it. If I push menu, it should, unless something's wrong, usually it should get the LCD working again. So I notice that's a little quirky. It doesn't always work. I just add a little bit of delay also between those little commands. We just finished programming. Now it's getting ready to. Alright, now it's done. It's resetting. So playing around, as long as you got the LCD scrambled, but it's still kind of taking some inputs, that seems to be when I can restore it. There it goes, restored. So just depends. Well, I know when I was using parallel LCD mode, which uses more wires, it was foolproof to always just add somewhere in my code where I hit a certain button, or just every once in a while I would just send out the initialize commands to reinitialize the LCD, because the LCD, whenever you first power it up, you first go to your thing, you send that LCD initialize, which basically tells the LCD screen, not this piggyback on there that's a serial to parallel converter, but you're telling the screen what to expect, and all that kind of stuff. Before that, though, you're initializing this chip, which is the IC squared serial, or I square C serial communication. You're setting all that up. So I set that up first, address, all that kind of stuff, which is all in this other little source that's not in my main. I just have it loading it at the beginning. Somebody else made it, I don't remember how to change anything in it to make it work for me, but so this I2C LCD subroutines, functions, or whatever you want to call them, to load in. Somebody else made this, and out of all the ones I saw, I kind of like this one. Seems to work good for me. So this is that function, I2C master, you know, and then from here it kind of runs this other stuff. Which, so it does that, and then it does the other one, which sends an installation into the actual 4-line screen, you know, like these. If you don't have a pig, well, that has a piggyback, but I have some that don't have piggybacks. When you did them in parallel mode, looks like I've kind of gotten used to making a bunch of these, and these are all kind of interchangeable. And the thing I think I can do is, I don't see why I wouldn't, but is to put more than one of these on a communication cable. And when I'm thinking of when I redo that, if I get if I get a waterproof enclosure, I was almost thinking of just putting it outside next to the unit instead of having it up there. I just have to go outside though. But if I do, I thought, well, I'll just run another comm cable and put another LCD in here so I can see all the readings from in here. Who knows? I don't know, I haven't made up my mind, but anyway, this is supposed to be a quick video. I was just kind of throwing something up just for all the geeks out there. This is what I've been geeking out on. So pretty cool looking board. It always sucks when I forget a couple components. Again, like these are the regular cheap tactile ones, but I actually designed it to use these, which I ordered separate. They work. They're just not as, the tactile isn't as obvious as a nice satisfying click. So it's both the same thing. I made it for surface mount. I just have to bend the legs underneath there and stick it on there. But I thought this all came out pretty cool, how I did my thermistors, my voltage dividers, added some filter capacitors, all surface mount. Pretty bitchin'. One thing I screwed up on was this header here. See, it's supposed to be to this, the 2.54 millimeter spacing, and it's like less than that. You see they're all bent because I had to bend them a little wider. That's for my programmer, which I usually used this header, but it won't fit on there, smaller, so I made this adapter to the smaller one. I don't know what the pin spacing is, but it's smaller, and I actually had a kit for those also, luckily, but I didn't have any 5-pin ones. I only have up to 4, so I do a 3 and a 2 and just plug them in right next to each other, right there. So it's an adapter, so whatever. I have to use that adapter on all these boards I made. Can't win. But anyway, that's it. That's my circuit. It's basically that, which I like to print out, and in this case I did, and I rewrote my changes on here just for you, just for my water heater hybrid AC unit here, adding a couple more inputs and noting it, you know. It's on port A0 and that's going to be analog 0, and the other one's going to be analog 1 and A1, where some of the other ones are on odd even numbers though. Like port A5 has analog 4 on it. You have to remember all that stuff. But this is what I made, and you kind of, you know, got it. Y1 is coming from here, Y2, and like I said, these are all weak pull-ups. And here's the optical isolator. So I'm trying to tell you guys, here's your optical isolator, your photo transistor. Light comes from this isolated circuit. It's 24 volts AC. You know, it conducts, and this pulls down. But forgot the capacitor, which needed to go right here on each one of these. Just needed probably a little good surface mount one or whatever. Oh yeah, one more thing. As this room just continues to cool while I'm in here, and it doesn't help that, like, the wife just came in a few minutes ago, and every time they open the door, some heat comes in from the garage. But water heater, see, it's now up to 136. It's 10 degrees over set point. That's still nothing to really worry about. But all right, I've been in here for a little bit watching videos, and it's 140. So nowhere near the danger zone, but it definitely gets the water heater cranked up there. Anyway, with that, don't forget to like and subscribe and all that stuff. Catch you guys later.